Thank you, Chris. I think enough has been said with regards to what could or could not happen in the future with the energy grid. But I think it's important to realize what is the most likely scenario to happen, which is that one of the presenters mentioned that the solutions in the future are not going to be a cookie cutter type of solution into which all of them are the same. So what you will see is the forces of the market moving into a liberal market, into which not everything will be on the hands of the government, and you will go from a monopoly into a well-diversified market that has a day-ahead type of trading structure. And this is an important part because technology needs to follow the market, not the market following the technology. So in other words, the pricing of electricity will change, or the way the electricity is being priced. So at the moment, we don't have a system that reflects a willing buyer and a willing seller. What we have is a pyramid style type of scheme into which actually the government dictates how much energy should be available, which is not how actually the rest of the world and certainly the intraday system actually operates. Some green shoots of the country moving in that direction. I'm Spanish. I'm going to try and put technology and how the electrical market in Spain looks together, so you can see a potential scenario for South Africa on a few short years, okay? So the NTCSA will be the catalyst of all of this, because at the moment you have too many intermediaries that doesn't allow the willing buyer and willing seller to connect. So the NTCSA will be the catalyst for this to happen, to have the willing buyer to be able to actually buy from the willing seller, which, by the way, doesn't have to be Eskom, can be anybody. So yes, Eskom will be there, and in the foreseeable future, if you see the first presenter, they will have still a sizable amount of energy being serviced into the grid, but that does not mean that private industry and private customers are not going to take the lead. I have a different view with regards to why there is no load shedding. There's no load shedding because private industry is much quicker to make decisions than government. And the amount of BSS and solar that has been installed in the last 3 years has been incredible. So that is your reduction on perceived demand by Eskom, and we'll see that now. So the energy costs are going to morph. And today we talk about BSS as something that will go and actually cure load shedding, but and I apologize if I'm raining on somebody's parade and the presentations, but I think the load shedding will disappear. Because higher energy costs will lead to reduced demand, and it will actually lead to people actually installing even more BSS. So what you will have is rather energy costs responding to weather and to the time of the day. So you will actually have to decide if you're going to use energy or not. And again, the lead on this will be with industry and commercials, will not be actually utility scale plants. Okay, so the penetration of renewables already in South Africa is very high. But we'll see now a couple of slides of what happened in Spain and why Spain is actually experiencing an explosion on BSS installations at the moment. So this is the same version of a previous slide in the presentation, one that actually shows February, but this shows actually April. And you can see there actually how what Eskom perceives as residual demand, in other words, of the energy that is actually Eskom is servicing at that time. You can see actually how we actually have developed already a dot curve. And this is before any of these utility scale projects, which are coming online in the next 3 years, actually go online. So if you put 2 and 2 together, you will realize that at this rate, we'll have way too much electricity at certain times of the day. So that's going to affect the cost of electricity if we are into a willing buyer and willing seller type of scheme. So how does the electrical market work in Spain, and how will this be very similar to what will happen in South Africa? Well, let's fast forward a little bit. And if you take the first presentation, this ties in perfectly. If you see the amount of renewables on that presentation, you'll see on Spain this year, January to June, approximately 60% of all energy served actually came from renewable sources. These being solar, being hydroelectric, or being wind. And a small proportion actually came through the use of a BSS. So in Spain, we have the OMI, which is the equivalent of the NTCSA. It's actually a bridge that allows the producers and the distributors to actually buy and sell electricity to each other. And then we have another layer in the market, which is your resellers and your customers, which actually buy from these distributors and sell to the customers. And then you have customers which are big enough to buy from the producers. So how this works in real life? So today we make an application for the energy prices of the next 3 years, highly inflexible. So definitely not a reflection of willing buyer, willing seller. In Spain, every single day, every single producer actually puts forward the price of their energy for every hour of the day. And in this case, the distributors do the opposite. They actually put forward a bid for what is the maximum buying price that they will actually buy at each and every one of the hours of the day. Where those two curves actually meet, intersect, that is the agreed price by the NTCSA of Spain of what the energy should cost during that period of time. So any offers which are to the left of the P1 point are considered as accepted. And any of those IPPs, well, they have contracts which actually force them to deliver that amount of energy at that cost. So then you will typically have coal, right towards the left, which is really not very expensive at night. And then in the middle of the day, you will probably have solar, which is very inexpensive. And then at some times of the night, you will have wind. So now, if you hear what I said previously, the problem with this is that it's very dependent on weather. So if you have 60% penetration of renewables, then what happens if the weather is not in your side? And that happened actually in Spain this year. So this is an example of volatility in price. So this was one day on January of 2021. There was a storm called Filomena. And what you see there, actually on the light green, is actually what was agreed the day before the storm, the price was going to be. And what you see towards the left, 110 euros per megawatt hour, is what actually ended up happening after the weather was a lot worse than what actually was anticipated the previous day. Because in the intraday method system, you are allowed to actually modify your offer up to a certain amount of hours before you have to service your energy. So there is a very high value for energy, 110 euro per megawatt hour. But what happened 20 days later? So we had a beautiful winter day on a weekend, super great sun, great wind. All the electricity that day went from 110 euros per megawatt hour to 1.95 euro per megawatt hour. So this is a true reflection of what happened when the penetration of renewables are high, volatility. So then, of course, some of the volatility will be passed to the end customers as high average rates, because private enterprise has always to win, has always to make a profit. So what are the opportunities? And I'm angling my presentation from the point of view of the 150 EPCs that we have in the call. What are the opportunities on this market? Well, in the same way that PPA provides a very reliable and predictable pricing of energy on many years to come, BSS applied correctly to a customer energy load profile can be extremely profitable to a customer as well. Because if something is for sure, this is the future we'll see a time of use, a very time of use oriented type of tariff schedules, both from municipalities, from new resellers, which actually will appear once the law is changed, and that's part actually of the government plan, and from people that are actually signing directly power purchase agreements from IPPs into industry. So those will actually be time of use based type of agreements. So then BSS will have a great role to play there. And I have put together a small example here, using something that anyone will be able to relate, not something too abstract, something actually quite real. So in this case, we're going to actually see the effect with today's rates, not with the future, not with what's going to happen, but with today's rates of an ESCOM customer, which actually has a high voltage, medium voltage supply with time of use. So in this case, the customer has a mega flex tariff. The customer is actually a residential complex, as many as you can see around you, with many blocks. Each block actually has its own mini sub. Of course, the complexity supply on 11,000 volts. So here, what we actually do is we actually use our BSS not for load shedding, because our views load shedding will not be here for very long. We use the BSS as a way to actually hedge and to be able to lower the average cost of energy of this customer to the absolute possibly lowest value that you can achieve with a minimal amount of investment, because the BSS is still a costly item. So how this works in real life? So this is a large complex. many MVAs of demand. The battery is not a multi-MVA peak power type of battery. It's actually a tailored approach into which we guarantee that we can twice per day, 365 days per year, whether it's sun shining or there is rain, we can actually complete an arbitrage cycle. So as you can see here, if your battery is way too large, you might have too much energy, you will not service back to yourself. And if it is way too small, you will have actually a lost opportunity to have made money in arbitrage. So in the case of this complex, an analysis has been made, and then an optimal size of battery bank has actually been achieved to be able to do full 100% energy usage twice per day, 365 days a year. So how that looks in real life, well, that's in a small schematic. Well, a little punt to our own company, that's our BSS solution, RivoMax, which is a modular standardized solution that you see there. So you see we have a supply, which is a 4 MVA supply, but we only have a 500 kilowatt inverter because I think that inverter is only there for one reason, which is to do arbitrage. So we can offset peak energy with standard energy or off-peak type of energy. For this example, we have added as well, we have sprinkled some amount of solar input to it. So we put 500 kilowatt of PV because that energy will actually replace the standard time energy that actually flows through this unit. So as you can see, what we're doing is we're exporting into the RMU of the complex. The complex is still consuming energy from ESCOM. But how does this affect the average cost of energy of this complex? See the size of the system versus the size of the demand of the complex. So what you can see here is that in some applications, and again, even if the whole intraday situation happens and we have very variable electricity, you will still have the resellers in the last mile, which will still have demand charge to actually justify the infrastructure. So for a customer that actually do have a predictable time of the day where the peak loads are happening, like in a residential complex, it is guaranteed that that small amount of offset, in this case 260 kilowatts, will come off their demand charge. So it is, and it's happening 365 days a year, regardless if there is good weather or bad weather. So that's the first benefit. The second benefit, we are actually offsetting all the energy that we have on those orange bars, which is peak time energy, with either a blend of standard time energy and solar energy, which has a very low cost of energy, and or off-peak energy, which actually is the blue bars that you have there. So if we believe in that simulation and we go on, actually we see the next slide, you can see the before during a winter month, okay? So what is the breakdown of peak energy versus the rest of the energies, okay? That gives us an average cost of kilowatt hour of 2.77 in this case, with a demand of 544. What happened after we implement this project? We go from 28% of peak to 10% of peak. And our cost goes down from 277 to 183. And our demand is guaranteed to have actually decreased by about 230 kVA. So this intervention alone, we are already at this point in South Africa at an energy cost point that we already went past the threshold into which the investment cannot be repaid by the savings. So VSS has an open road in front of it to actually fulfill the mission into which the advanced markets is doing, which is actually to do energy arbitrage and levelize the cost of energy of the customer. So in this case, the cost came down by 35% with a very tailored approach. So now you will think this is only going to be commercial customers and industrial customers doing this. No. We actually have the first company that actually obtained a distribution license that is not actually ESCOM or an IPP for energy. So there will be many, as it happened in the rest of the world, private companies distributing energy, which will be installing VSSs to be able to hedge their cost of energy, not only your commercial customers. So is PV and arbitrage a good combination? Is the best. Okay, it's a very efficient setup. Arbitrage happens 365 days a year. So it is predictable, and therefore you actually can predict the return of investment of your plant, and effectively you can actually fix your energy cost reduction and guarantee it, which is very difficult if you only do it via solar. So for extra information that you might require, that's our contact details. And I think my last line before Chris goes to the next presenter is, the BSS is already here to stay. It's going to be a common fixture in every one of your customers in the years to come, regardless of how big the penetration of renewable is in the market.